In this video, I want to make a quick summary of 4 cases I like to teach for this chapter. Fundamental theorem of calculus part 1 says that if a function continues on the closed interval a and b, then we can have a new function which will be an integral from a to x. That means if lower limit of integration is fixed, but the right one is not, so we're gonna call the variable x. X can be smaller or bigger. Then let's see, integral is the area below the graph. The area will be accumulating, getting bigger if x is getting bigger, or smaller if x is getting smaller, and so on. So it's called a cumulative area. But also the theorem says that this function will be continuous, and if we differentiate this function, we're gonna get the function inside of the integral with the variable x in it, because we're differentiating with respect to x. It looks a little bit confusing, so I like to teach 3 cases that help you to be fast when you work with your homework or exams. Case 1, the simple case. Just plug in, or basically substitute in. When you have an integral from a to x, let me use some kind of specific example so you feel a bit happier about this. X cubed plus 3, and as you remember, it's not x inside, we're using a dummy variable. Let's call it t cubed plus 3 dt, and now we're differentiating this with respect to x. And whatever I just draw is not a very professional way to do it. I just wanted to show that it is exactly a derivative. Usually you will see the notation d with respect to x of that integral. Then you just plug in your x into the function x cubed plus 3. And it doesn't even matter what this a is. It kind of have to be part of this restrictions of the theorem, so f should be continuous at that a. So be careful with that. But in all examples you will see everything works out well. Case 2. Let's do first switch the sign, or basically flip. Let's put it like not a professional language here. That's my favorite one, I guess. When you have integral from x to a, and now I will have the same function, t cubed plus 3 dt, and I'm differentiating that with respect to x. As you can see, how would we take it to the case 1? We will flip the integral, so it's going to be from a to x of t cubed plus 3 dt. But we remember the rules. You cannot just flip and claim it's the same thing. We're going to put negative in front of it. And then don't forget, there's still derivative, d dx. So we're differentiating this integral, but with a negative sign in front of it. And because negative can be just taken out of differentiation, the answer will be minus. And then case 1 says just plug in. So x cubed plus 3. Or you can rewrite it as negative x cubed and minus 3. Here you go. Just plug in, flip, so the sign will change. In case 3 will be the most confusing one, but if you practice a little bit, it's not that bad. Chain rule, your favorite one. I know, right? So you will have an integral from a, and let's say it's going to be not x, but let's say x squared. Yeah, let's do x to the 4, then it will be even more fun. Same t cubed plus 3 dt and derivative of that. Now, this still follows the first step, just plug in. But this time we're plugging not x, but x to the 4 into t. So it's going to be parentheses, t was cubed plus 3, but now I have x to the 4 versus just variable x inside of those parentheses. Now this is also not the end, because we need to follow the chain rule. There is a function inside. We need to differentiate this function inside, so we will have to do times, and that's where the chain rule comes in. times the derivative of the function inside. Do you remember this phrase? We just learned in this class. Times the derivative of the function inside. So 4x cubed. And now you don't have to simplify unless we tell you to, or unless you're told to do it for your homework. But it's going to be x to the 7 or x to the 12. Which one is that? Correct. X to the 12. You multiply the powers in this case. Plus 3 times 4x cubed. 4x cubed, I'm reminding you, came from differentiating x to the 4 because of the chain rule. And maybe let's distribute one more time. 4x, is it x to the 36 or x to the 15? Correct, x to the 15. This time we add the powers 12 and 3 plus 12x cubed, or you could keep everything factored in the factored form if you want to. So this is probably going to be the most challenging case, and that's why it usually goes to the exam, the chain rule case. So make sure you understand this one good, and don't forget to multiply by the derivative of the function inside, which was x to the 4. Finally, the last case is a combination of cases we just covered. Case 4 is mixed. As always, math accumulates the knowledge we just had, and we're going to have x cubed to the x to the 5, and again t cubed plus 3 dt, differentiating with respect to x. What would you gonna do here? We're gonna break this integral. So remember, the derivative is still in front of it. It's gonna be dx, and I'm gonna open huge brackets like so. And I will break this integral into two integrals, which is going to be x cubed to a t cubed plus 3 dt plus, do you know what I'm going to do now? Exactly, it's going to be, next integral is from a to x to the 5 t cubed plus 3 dt. We can do it because the function was mentioned to be continuous and differentiable, and we're working with integrals, so there are properties of integrals also involved. There are some tricky cases when this a have to be chosen carefully in case if there's a vertical asymptote and so on, but in this homework you will not get those cases. So how would you deal with those two integrals? The second integral is chain rule case, right? So we're just going to do chain rule and substitute x to the 5 into t, just like we did right before that. So case number 3. And then the first case is not ready yet. We need to flip first. So case 2, flip, and it will be negative. And then case 3, chain rule. Does that make sense? And then you plug in again x cubed, in this case, into t. And then don't forget, each time when you use chain rule, you have to multiply by the derivative of the function inside. For the first integral, it will be derivative of x cubed, and for the second case, it's going to be derivative of x to the 5. So I will do it quickly and see if you can catch up. Negative sign shows up because I have to flip the integral, so it starts from a, and then I will substitute x cubed into t. So x cubed now is cubed plus 3. I will also put parentheses outside and multiply by the derivative of x cubed. So it becomes 3x squared. And I'm done with the first integral. I'll put it in brackets for you. Plus, and now I'm differentiating the second integral. You don't have to flip that one, so this already is better. X to the 5 raised to the power 3 plus 3 parentheses multiplied by derivative of x to the 5, derivative of the function inside, which is 5x to the 4. Let me put in parentheses and close the brackets. And that is the result for the second integral. That is a final answer. You can distribute and collect terms, but I will leave it as it is. Maybe you should need to stare at it for a couple of minutes to comprehend what did I just do here. And then you practice homework problems and you become very good at all of those 4 cases. Thank you for watching, and please work hard.